Panando, myself, Lakshmi Prasanna Kanidi. I'm working as an assistant professor in PSCMRCET. Today I'm going to explain about satellite subsystems. The satellite subsystems are majorly classified into 4 types. The first one is power subsystem. Second one is antecedent orbital control subsystem. Third one is telemetry tracking and command subsystem. It is shortly known as telemetry tracking and command subsystem. And fourth one is communication subsystem. In power subsystem, we have solar array, battery, and power supply control loop. Thousands of solar cells are placed on the surface of satellite. Solar cells are photovoltaic cells, which convert sun energy to electrical power to run the spacecraft. Each solar cell generates 1 to 2 kilowatts power, and its conversion efficiency is 12% to 15%. Sun energy is not there if the sun energy is not there to run the spacecraft. At that time, battery will be used. The power supply control circuit controls the PSC controls the whole power subsystem. And the second one is antecedent orbital control subsystem. It is used to control the orbit of the satellite and maintain the stabilization and its position. The subsystem consists of 4 major parts. Here the parts are sensors, and here we uses the earth sensors and sun sensors. And the second one is propulsion system and attitude control and orbital control subsystem. This subsystem classified into 4 parts: sensors, propulsion system, attitude control, orbital control. In sensors, we have earth sensor, sun sensor. There are some forces acting on the satellite. These forces are there are some forces acting on the satellite, so it changes the satellite position. There are asymmetry of Earth gravitational field, gravitation due to sun, planets and moon, pressure due to solar radiation, magnetic field of Earth. And sensors, we have in the Earth sensor, sun sensors. The propulsion system, in propulsion system, we have low thrust actuators, high thrust motors, and space shuttle. Low thrust actuators are used to correct the antecedent orbital corrections. High thrust motors are used for velocity increment. Space shuttle, it provides the velocity increment whenever the satellite is required for the transfer, and is required to transfer the orbiter. And attitude control. Here we have passive system and active system. It's used for the detection of satellite attitude and compare with reference axis to determine the corrective torques. Orbital control and is the orbital control. It controls the satellite orbits, maintaining the stabilization in its position. And overall, here we have the attitude and orbital control subsystem. Here we have the encompass, propulsion system, attitude control and orbital control. In sensors, we have depth sensors, subsensors. In our propulsion system, we have low thrust actuators, high thrust motors, space shuttle. And in attitude control, we have passive system and active system. Telemetry, tracking, and command subsystem. Coming to the telemetry system collects the data from the many sensors that fitted on the body of the satellite, and it sends the particular data to the controlling earth station. And coming to the tracking system, and it is located on the earth station, and it provides about the range, elevation, and azimuth angle, so that any changes in orbital elements to correct it. Coming to the communication subsystem. In communication subsystem, it consists of different types of antennas and having the different types of transmitters and receivers. And it's called as a transmitter and receivers is called as a transponders. In transponders, we have the bend type and regenerative type. Here, frequency converter is required to convert the uplink frequency to downlink frequency, and uplink frequency receive the signals and transmit towards the satellite systems, and downlink frequency and receives the signals and transmitted to